Welcome to LibreOffice Pythonista. If you're a spreadsheet user and a Python enthusiast, you're going to love this. To get started, we need to download LibrePythonista. A good source for that would be the LibreOffice Extensions website. So if we were to search for LibrePythonista, you can see we can find it here. And then we'll just click on Download Latest and save a copy. And now we have a copy saved locally that we can install. An alternative is also to go to the LibrePythonista repository website, which is at this address here, as you can see. And then in the distribution folder, you can find also the latest release published there. So there we could just click on it, and over on the download raw file, we can click that and also save it that way as well. But seeing as we already have a copy, we don't need to do that. Okay, now that we've downloaded the LibrePythonista extension, the next thing to do is to go to Calc and install the extension. And we can do that by switching over to Calc, going to the Tools, then clicking on Extensions. At this point, we can click on the Add and go find the one that we downloaded. It's in our Downloads folder. Open and accept the license. And this will start the process of installing. And at this point, we just wait for LibrePythonista to show up in the dialog. Now that we see it, we can go ahead and restart LibreOffice. Now that LibreOffice has restarted, the extension now goes through a process of installing its Python dependencies such as OOO development tools, Pandas, and MATLAB. This takes a little time based upon your system. Now that the extension has been installed, all its requirements, it is a good practice to check for updates. The LibreOffice extension site may not have the most recent version. To do this, we'll go to Tools, Extensions, and we'll click on Check for Updates. And we'll just see what we get here. And you can see there is an update. So in this case, I will apply the update by clicking on Install. And it's going to go through a process of downloading and installing the updated version. That should just take a few seconds. Here we go. Okay, at this point, we are click Close, and we'll need to restart one more time. So we'll restart now. Don't save. Now that Calc is restarted, we can take a look and check the version that we currently have. And we can see here that this is the latest version. So mission accomplished. Okay, LibrePythonista is installed, but there may be one more step, as you can see here. I'm going to open this example. And once it's open, you can see that the recalculation and things are done. However, when I click on the DataFrame button here, we should get a pop-up menu, and we do not. This is likely because the settings have not been set for macros to be able to run. So in order to do this, we need to go into Options, and we'll need to go into Security, and under Macro Security, you'll want to set it to medium, probably not low. If you set it to low, everything will run, and that wouldn't be preferred. But medium is a good solution because it asks you to confirm before running something. So we'll click that, and then we'll apply those settings. Okay. And then we'll just restart. Okay, now that Calc is restarted, we can open up our last page, look at the example, and now we will see that we have an Enable Macros option. So we'll click that. And now when the page finishes loading, you can see now we have a menu that we can edit code and do other things with. Once Calc has reloaded, you can see there's a new LibrePy menu and also a new toolbar. If you can't see the toolbar, then make sure that the LibreOffice menu is displayed by clicking here on the menu bar icon. On the menu, click the View Toolbars LibrePythonista bar. Now you will see the toolbar. Let's get started together right now. The first thing we need to do is to get into Python mode. One way to get there is to click the Insert Python button. Keep your eye on the cell. You can see it inserted a control that gives us access to the Python for the cell. This puts a control into the cell, indicating that it is a Python cell. By clicking on the control, we can access the menu. Also note that the menu can be accessed by right-clicking on the cell and choosing Pythonista. By clicking on the Edit Code option, we can open the code editor and start inputting Python code. As our first example, we want to give some insights into this data set. If you are working with data, then the first step is to send your data to Python, because it needs to be able to see it to work with it. The way we can do that here is by clicking the control and choosing Edit Code. With the code window open, we can take advantage of the Insert LP function option. This will pop up the selection dialog. From here, we can select the range that we want for our data frame. After I make a selection, I can select the rest of the used area by using the keyboard shortcut Ctrl-Shift-Down arrow key. Notice what we get in the code dialog box. We have our data range, header equals true, is automatically picked up, and everything is wrapped up in an LP function. Once OK is clicked to accept the changes, we get what is called a data frame. If you know Python, you know what this is. If not, it's basically a condensed version of your table. It's a two-dimensional data structure that's all sitting in a cell. What is being displayed here is a control that represents a Python object. I can click the control and choose State View as Array. Now I can see the entire dataset as calc values. The dataset takes up a lot of space, so I switch it back to DataFrame by choosing Pythonista View as Python Object. If you want to get glimpses of what is inside, you can click on Display Card and you get to see the beginning rows and the ending rows of your dataset. At this point, it is worth noting that the cell that the data frame resides in is a custom calc formula. One quick way to access the cell that is filled by the data frame control is to click on the control and choose Select Cell from the menu. The custom PY.C formula is the starting point for Python to interact with the spreadsheet. The PY.C formula takes three parameters. This first one is the current sheet. The second one is the current cell. The optional third parameter is used to pass in the range that this formula currently gets its data from. When a range or a cell is passed in as the third parameter, it ensures that the formula is recalculated when the range of cells is updated, providing, of course, that the auto-calculate is turned on. When a Python object is added to a cell, it will automatically fill out the first two parameters. If other Python objects are detected on the sheet, then the address of the last Python object previous to the current one is automatically added as the third parameter. This can be manually changed or removed if needed. For example, you can see if I select the data frame and look at the card right now, you see the display card, for instance, shows the first entry as having 900 in sales. If I come over to the first entry in the data and change that to, so let's say, 502 and hit enter, now we can go back to the data frame, display the card, and you can see that the new value is 502, and that is because the third parameter instructs the data frame to be updated as soon as there's a change within that range. This data frame is a fundamental structure of a specific Python library that is called Pandas. The Pandas Python library is great for data analysis. You will need to know that name if you want to look up other functionalities in Python's libraries. I will talk a bit more about pandas and libraries later. Let's take a look at some of the cool things that you can do here. I'm going to go to another cell and I'm going into Python mode by inserting another control. For the code, I'm going to put in LP, and in quotes, I will reference the F2 cell. Lastly, I will call the describe method. I'll click on OK to run the code. As you can see, I get another data frame back, but I am going to switch to calc mode by choosing State View as Array. Depending on what version of Pandas that you got installed for your system, you may see the date column included. On older versions of Pandas, the date column would not have been included. I'm interested in describing only the product columns, so I will edit the code and make a change. I am adding in column products. The way you reference columns is by opening the square brackets and typing in quotes the name of the column header, this case product, and close the square bracket. I have some information about products. There are 72 products, 12 are unique. The top product is laptop bag black because it occurs 6 times. It is a quick way of getting insights from your data. Now, if you're planning on using that data you sent to Python and doing different types of calculations, then it helps to give it a name. This way you don't have to reference the cell via the LP function. The way I will do this is by going to the first data frame and editing the code. With the code window open, I will assign the function results to a variable called df. Next, I will edit the product description to also use the df name. Now, when it comes to other types of calculations based on this data frame, I no longer need to reference it by referencing the cell. Instead, I can just type in df and that's it. Another shortcut that we can use is to avoid using square brackets. A neat thing about the Pandas library is that it transforms headers into attributes. So, as long as there are not spaces in the header names, you can actually type them out. I can type in the data frame dot the header dot describe, and when this is run, I get the same result. Keep in mind, if the headers have spaces, then you will need to use the square brackets. There are lots of functionalities in the Pandas library. Some of the simple ones that you may be familiar with in Calc is, for example, the sum or the average function. So let's say I want to use the Python and sum the sales column. I'm going to go into Python mode, but I'm going to use the keyboard shortcut Shift-Control-Alt-L. Shift-Control-Alt-L sounds like a complicated shortcut, but it's actually easy to reach for on the keyboard. In the code editor, I am referencing the df name I previously gave the data frame. I want to sum the sales column, so I'm going to type df.sales. It does not have any spaces, so I can reference it with a dot. Now I can add the sum method and click OK. Now I get the total of the sales column. I can confirm this by selecting the cells in the sales column and check Calc Sum below. Now I can format the cells into a currency. So if I want to get the average, I can use means here and get the average. All of this you can do with simple calc formulas, so why do we need Python? So let's take a look at this step further. Let's say I want to get a total sales value for each date. Notice that the dates are repeated, but I want to aggregate them for each date, similar to what you would do in a pivot table. I'm going to go into Python mode. Now, I will reference the data frame, which is df.groupBy. I want to group everything by the date column, and I want to have the total values from sales. I'm going to go with .sales.sum. Now I click on OK. Now I get a series returned as a Python object. I want to see the series as a calc data, so I will choose State, View as Array. The dates may show up as numbers. This is just a formatting issue and is corrected by selecting the cells and changing the format to date. The first entry in the series is for June 15, 2021. If I select these values from the data, you can see they have a sum of 999. So what if we wanted to see now the data on a monthly basis? Well, check this out. I'm going to go inside of the group by function, and I'm going to use a class called PDGrouper. My key is equal to the date column, and my frequency equals, I'm going to put M here and close the bracket. I run this and I get sales on a monthly basis. So you might say, well, a pivot table can do this. The great thing about this is that they are formulas. If I change this value, let's say 500, then you can see the data series and the value for January updates. Something to keep in mind is you always get the last expression from the code for the cell returned. So you could be writing a lot of code in a cell, but only the last expression results are returned to the cell. Let's take a look at something even more cool. I'm going to modify the code for the data series and chart a plot in the cell. I'm going to call the data series for chart. I'm going to plot this series. I'm going to do a for chart.plot. I want to put a line chart. My x-axis is going to have my dates, which are in the date column. My y-axis is going to have the sales values. And the kind of chart I'm going to plot is a line chart. Finally, to plot the chart, I will call plot.show, plt.show. In LibrePythonista, plt.show must always be the last line to show in a chart. I'm going to run this, and I get a tiny little line chart in a cell. You probably can't really see this, so let me go and merge the cells. And we get to see our monthly sales values. How cool is this? If I want an area chart, I can edit the code and set the kind equals area. If I want a weekly, I can set frequency equals capital W. I like the line chart, so I will set it to kind equals line. If you're wondering how to come up with this syntax, how do you come up with the classes and syntax, there's great documentation on this library at this website. You have lots of information on this web page to help you get started and lots of code to play around with. Plus, there is AI. There is Copilot and ChatGPT that can help you when you get stuck. Just double check your results and make sure it is what you want. Before I move on and show you even more cooler stuff, there is something important that I'd like to keep in mind, and that is the calculation logic of Python cells. Python cells are calculated from left to right and top to bottom. Notice here, first, I've created the data frame, and here, the code to display the average. If I open the logging window and then put code in for the average before the data frame, it would show an error. In the logging window, we can see that the df is not defined. That is because df is not created until cell F2, which is after A2. In short, because the cells calculate from left to right and then from top to bottom. Let me show you some cool examples from the default libraries that we have. Here I am using the pd.melt function to restructure this data set. So, I have a quantity and a sales in two separate columns. When I use the pd.melt, I can bring them into the same column. If you have a look at the code here, it is very simple to write this. I just need to mention my non-value columns, which are date and product, and my value columns, which are quantity and sales. And it does the whole restructuring for me. Now, another cool one is query. Take a look at this. I'm going into Python mode, referencing df, which is the data frame that was previously created. I'm going to use query and put this code in. What this does is it takes a look at the sales column. It grabs everything that is above 2000 and takes a look at the product columns to see if anything contains the word black. So, This is similar to the query function in Google Sheets, which was also similar to the syntax of form of SQL. When this is run, a data frame is returned by default, but I'm going to see the calc values. I get everything that has the word black and sales is above 2,000. Now let's move on to something else. We can create charts like this. I have a small multiples returned as a single object. Take a look at this one. This is a bit more complicated, but I also wanted to show you that you can write longer script and get Python to do what you want. So here, I just have dates and customers from 2020 to 2023. And what I wanted to do here was this. I want to return the last 4 years, and I wanted to arrange the charts besides one another. I also wanted to make sure that the y-axis is showing the same values, so that I can easily compare each of these with one another. I did not think to do all of this on my own. I didn't know I had to flatten the axis, so I asked Copilot for help, and it helped me get what I wanted right here. Now I've even added labels to this, and you can do all of that in Python here. You can set the title, set the label, and so on. This might be my favorite part of the video. What we're going to do here is this. We have a calc named range, and we have some feedback in each row. What we want to do is grab any ULRs that we have inside of each row. The tricky part is that they might be in the middle of the text, and the pattern isn't so obvious. So sometimes they start with www, sometimes we don't even have that, they just end with .com. Sometimes we have HTTPS, and some might just have HTTP. Some might not even have a link. What we are going to do is just grab any ULRs in there. So here you can see I am grabbing both of these in the cell, and then we're omitting this one because it didn't have any links. Then we have this and this. How can we do this? The great news is you can import any Python libraries or modules that might not be in there by default. So the ones we use are there by default. The Pandas library for data analysis, Matplotlib for data visualization, Seaborn, NumPy, OOO development tools for API access to the LibreOffice. But Python has so many different libraries and modules. There are ones for AI, for web, for regular expressions. In this sheet, the feedback data is set as a named range. When I select feedback from the drop-down, you can see the range gets selected from A3 to A50. When I click on Manage Names, we can see that the details in the pop-up dialog. In this case, the named range is stored in Sheet 1. LibrePythonista's LP function can use named ranges and data ranges, as we will see in a moment. In the first cell, RE is being imported, which works with regular expressions. All I have to do is go into Python mode and import the library or module, and I've returned RE loaded. That's just because I want to see something in the cell to let me know what the Python cell is doing. After the RE library is imported, I created a data frame. In the next cell, you can see that the third parameter is set to the name of the named range, in this case, feedback. Remember, the third parameter is the data source for this data frame. By setting the third parameter to feedback, it instructs the cell to update the formula whenever there is a change in the feedback data. When the formula is invoked, the data frame gets updated and so on. For the code, the LP function first parameter gets set to feedback, which is the named range in the sheet. Headers is set to true, and also a new parameter is used, the collapse parameter. By default, the collapse parameter is false. By setting it to true, it informs the data frame to ignore the empty rows at the end of the named range. Now when a new row of data is entered into the named range, the data frame will dynamically expand. The next part of the code is to display the ULRs. What I have done is combine the patterns using this. This is based on the patterns that I can see in my dataset. This makes sure that anything that ends with .com or .org is included, and anything that has HTTPS or www is also included. Then there is a function here that grabs the ULRs, and this function runs on each single cell, so on each single text that I have in my data frame. Now you can also see the syntax here. Whenever you come across the hash sign, this means that this is a comment. You can comment the things out to add in some documentation into your code. LibrePythonista also includes a built-in logger that can be very helpful for debugging. The name of the logger is LP_log, and it is a standard Python logger. When we uncomment out these two lines, it instructs the logger to rate a line if the results has a value. The logger window must be open to receive log events. Now at the end here, we're just filtering out any rows that don't have ULRs. Now I will open the logging window by clicking on the toolbar icon. The logging window needs to be open in order to get the logging events from the LP_log logger. I will let the logging window go into the background. The great thing is this named range is dynamic. We can add in another ULR. So if I added in another ULR such as www.youtube.com, this is going to be automatically added to my ULR list here. Next, I can bring the log window back and we can see the results from the logging. Now we can see the log messages from our code. Note that the logging window can be hidden if you prefer. To bring it back, just click the icon again. Also note that the log window can be set to stay on top. This is useful for debugging.